students, I Mr. Simanchal Pandit going to start the class for Pharmaceutical Suspension Part 2. As we discussed in the last class about pharmaceutical suspension, it, it is having two phases. One is the solid phase, second one is the liquid phase. Solid phase is dispersed in the liquid phase is known as suspension. So now today we will study about sedimentation parameters. There are different type of parameters which we have to study in the suspension. The first one is known as sedimentation volume, that is denoted by F, or it is also denoted by H. For flocculated suspension, the sedimentation volume is a ratio of ultimate volume of sediment to the original volume of sediment that can be denoted by Vu and V0. So the rate of sedimentation, that is the volume of sedimentation F, can be written as Vu by V0, where Vu is nothing but final or ultimate volume of sediment and V0 is the original volume of suspension before settling. Here I have to tell that if you are taking in a measuring cylinder of suspension, we can see that it will occupy a certain height, and from after keeping that for a long time, we will see that the solid phase will start to separate. By keeping it for a long time, we can see that after, for example, for 5 minutes, 10 minutes, 15 minutes, 30 minutes, the height of the solid will decrease gradually. For example, if you are taking 10 ml of measuring cylinder and we are getting the height of 10 ml. So after 5 minutes, we can see that the rate of sedimentation will start to continue and the height will decrease gradually. For example, after 5 minutes, we can see that instead of 10, the height is 8, and after 30 minutes, the height is, for example, is 5. And after some time, for 30 minutes or 1 hour, we will see that the height is remaining constant. For example, here at 1. So it will not change for the long time. So we can see that we can calculate F value as the height, that is the Vu, as it told here, Vu divided by V0. V0 is the original volume of the suspension before settling. That is here, for example, we have taken as the 10 ml. And final or ultimate volume of sedimentation, how we can get, that is nothing but the 1 ml as I give in the example. So F sedimentation volume, here it will be F is equal to 1 by 10. So here there are different type of values can be found in different type of suspension. If that is generally less than 1, that here you have seen, here it is noted here, you can see when F value is equal to 1, then Vu is equal to V0. That means the flocculated is in the equilibrium and it will not show any kind of supernatant on standing. So the stability is best when F value is 1. When F is more than 1 and Vu is more than V0, sedimentation volume is greater than the original volume due to the network of flocks formed in the suspension and so loose and fluffy sediment. Here, as I told in the example, we can see here that there are 3 diagrams here, A, B and C. Whenever the time was 0, we can see that at the third one we can see the third diagram, the particles, the solid particles, that is the dispersed phase, was having the same volume as the dispersion phase, we can see here. So the F value was equal to 1 when the time was 0. After some time, we can see that solid phase, due to the action of gravity, it will start to sediment and it will occupy the lesser distance. The height will become little less, and after long time, you can see that it will again it is decreasing, and we can find out the ratio of F, that is nothing but the sedimentation volume. The sedimentation volume gives only a quantitative account of flocculation. Suspension, here the suspension is quantified by sedimentation volume, that is written as F. So next one, the next term is known as the degree of flocculation. Degree of flocculation is nothing but F divided by F infinity. It is denoted by beta. It is the ratio of sedimentation volume of flocculated suspension, that is F, to the sedimentation volume of the deflocculated suspension, that is F infinity. Beta is equal to F divided by F infinity. The minimum value of beta is 1 when flocculated suspension sedimentation volume is equal to sedimentation volume of deflocculated suspension. Next parameter is the Brownian movement. What is Brownian movement? Generally, if the suspension is of two type. One is generally we can see it as flocculated and deflocculated. Here in the deflocculated suspension, it will not form the flock. As I told in the earlier slide, here the particle will come close together and they will form the flocks, and this rate of sedimentation can be observed in the flocculated suspension. But in case of deflocculated suspension, we cannot find the rate of sedimentation as the particle size is very less. So instead of moving the particle down, it will move in a Brownian movement. Brownian movement is nothing but movement without a unidirection. That means if you are taking any kind of solid particle, these are coming down due to the action of gravity. But once these particles are made in very small particle, we can see that the particles will move in a zigzag motion. They will not move in a unidirectional movement, or they cannot fall down. So in this case, we are having the non-unidirectional movement, and that is also known as the drunken walk. As the people, as if the particles have drunk, it is not having the unidirectional movement. It moves randomly in rapid directions. The Brownian movement depends on the density of the dispersed phase and the density and viscosity of the dispersion medium. It is clearly indicated that if the liquid phase is having more viscosity, the particle will move slowly, and if the density will be higher, we can see that it will lose its Brownian movement, and the Brownian movement depend upon these two type of characteristic of dispersed medium. The kinetic bombardment of the particles by molecules of the suspending medium will keep the particles suspending, provide the size of the critical radius. Here in this slide, we can see these particles. Whenever we are reducing the particle size, slowly, steadily, it will reduce its effectiveness and it will move in a random movement. So due to the random movement, here the Brownian movement is denoted in this diagram. If the particle is about 2 to 5 micrometer, the density of the particle viscosity medium are favorable, it will show the Brownian movement. It is the characteristic of deflocculated suspension. There are different type of electrokinetic properties. Here I have given the example of the zeta potential here. Zeta potential means it is one of the layer which is the imaginary layer which is balanced by two opposite type of ions. All positive ions are close to the negative ions, and those are electrochemically neutral in nature. So here we can see that there is three type of layers are present. First one we can see that is the electroneutral region. How many positive ions are present, that much of negative ions are present. So there is no potential difference. But once we are moving away from this electroneutral region, we can see that the density of the two charges will vary. If those are near, we can see that second layer. In the second layer, the density is differing. There is negative ions and the positive ion is less. So there will be potential difference from the electroneutral region. If it is going further, we can see that it is away from each other. Positive ions and negative ion concentration varies a lot. So there will be more potential difference from the electroneutral region. So the potential difference from the electroneutral region to any other layer of any liquid is known as the zeta potential. Zeta potential plays an important role in the suspension stability. Why? Because if you are taking the suspending agent is generally having two part. One is the polar and second one is the non-polar part. So the concentration of the polar will influence the stability of a emulsion. For example, a suspension is going for the sedimentation, it is forming the cake, and in the sedimentation we found that it is having the more amount of positive ions. So we can choose the suspending agent which is having more negative than the cake formation. Here we can see that if the particles and the suspending agent having the more negative charge, that will get contact with the cake of lesser negative charge, they will form the repulsion, and due to the repulsion that will start movement. Due to the movement it will just increase its stability and the particle will move further. The next one is the zeta potential has particle application in stability of system, as I told earlier. Since the potential rather than the Nernst potential governs the degree of repulsion between adjacent similarly charged dispersed particle. If the zeta potential is reduced below a certain value, the attractive forces exceed the repulsive forces and the particle come together. This phenomenon is known as flocculation. As I told that the particle, when these are coming close to each other, due to the electrochemical nature, the positive ion will try to attract the negative charges, and this will form the small ionic colonies, and that is known as the flocks. And once flock is formed, the small flocks will again come close to each other and they will start to move against the gravitational force. But once more flocks will come close to each other, the gravitational force will work on them and the cake formation starts, and that is one type of phenomenon. This is known as the flocculation process, and after flocculation the saturation of flocculation lead to sedimentation, and once the sedimentation start, the cake formation start, and that is one of the defect for the suspension. And if it will become hard for the non-flocculated suspension, it cannot be redispersed again. The flocculated suspension is one in which zeta potential of particle is minus 20 to plus 20 millivolt. Thus, the phenomenon of flocculation and deflocculation depend on zeta potential carried by particles. Deflocculation and flocculation. Flocculated suspension. In flocculated suspension, form flocks, that is the loose aggregate, will cause increase in sedimentation rate due to increase in size of sedimenting particles. Here I told, if you are taking a glass of suspension, for example, we have taken the solid ingredient, we have taken the suspending agent, and we have taken the liquid medium. We can see that if we are making them stir together, it will remain in the liquid atmosphere for a long time. But once the action of the gravitation will work, whenever these are remaining stagnant for a long time, they will come close to each other and they will form the loose aggregate, and the rate of sedimentation increases once they are forming the loose aggregate. Hence, the flocculated suspension sediment more rapidly compared to the deflocculated suspension. The sedimentation depends not only on the size of the flocks but also on the porosity of the flocks. As I told, if those particles are coming close to each other, if the porosity will be more, then they will hang in the suspension for a long time and it will enhance their stability. And if those porosity is decreased, then the action of gravity will work on the particle and the rate of sedimentation will be higher. Here we can see the flocculation, how these are going for the flocculation. The particles are hanging in the liquid medium for a long time. This is the example of flocculated suspension, and when the time will increase according to the due course of the time, the particle will come close to each other and they will, and due to the attraction of the particle you can see it will form the flocks, and once the flocks are getting formed, you can see in the third one they will come close to each other, and action of the gravity and due to the Stokes law we can see the particles will come close to each other, they will start to settle down. Here the radius of the particle plays an important role, the density and the volume will also play an important role. If the density will be higher, the rate of sedimentation will be lesser. If the particle size is increasing in its radius, as it has seen in the first one, we can see the particle were separately, that's why the radius was less. So action of gravity will not work properly, and after that they come close to each other. So the diameter is increasing of the particle. So due to the increase of particle size, we can see the rate of sedimentation will be faster. So once the rate of sedimentation is furthermore it is coming down, we can see the particles are forming a cake. Here as the flocculated deflocculated suspension, that is a comparison here. The deflocculated suspension, if we can see, the deflocculated suspension will remain in the atmosphere for a long time and they will not form the cake as they are having the Brownian movement. If the particle size is decreased up to particular limit, and after that the acceleration due to gravity will not work, that is known as the critical radius, and once the critical radius is formed after the application, they will move in a random motion, and that does not have a unidirectional movement. It will move in a zigzag motion and the stability will increase and the rate of sedimentation is lower. And due course of the time, if the particles, the charged particle will come close to each other, and once they are forming the flocks for the deflocculated suspension, once the cake is formed, it cannot be redispersed and it will form a very hard cake. So for the deflocculated suspension, the rate of sedimentation is very less, but once it is forming the cake, it cannot be redispersed again. Here there are three diagrams. The left one is the flocculated suspension. Initially it was having the value f is equal to 1. Here you can see f is equal to 1 as the initial that height and the final height is actually equivalent. The 100 divided by 100 is equal to 1. But if that is a deflocculated suspension, it is also 1 at the initial stage, and if that will remain for a long time, it will also remain the same height. But in case of deflocculated suspension, we can see here that previously the height was 100, but after some time it will go for the sedimentation. Particle will come down and they will settle down slowly. And once the particles are settling down, we can see here the height is 40 here. So f is becoming 40 divided by 100. That means the final height is 40 and initial height was 100. So 40 divided by 100 is equal to 0.4. Here the f value is 0.4. State of suspension on stage after some time, that is written here. Here we discussed about the two terms here, that is for the flocculated, and we make a comparison the rate of sedimentation with the deflocculated suspension. In the first one we saw how the radius are increasing, how the action of gravity is working, and how these are forming the cake. And secondly, we just make a comparison statement with the flocculated suspension and deflocculated suspension. In the flocculated suspension, it will form the cake, the rate of sedimentation is faster, but in case of deflocculated suspension, the rate of sedimentation is slower. So now we can go for the next slide. That is the deflocculated suspension. In deflocculated suspension, individual particles are settling. The rate of sedimentation is slow, which prevent entrapping of the liquid medium, which make it difficult to redisperse by agitation. This phenomenon is known as the caking or claying. In deflocculated suspension, larger particles settle fast and smaller remain in supernatant liquid. So supernatant liquid, it will appear like cloudy. I am just discussing it again. As I told, in the flocculated suspension, the small particle will aggregate together and they will form the porous type of aggregation which will hang in the suspension for a long time. But once these flocks will gather together, they will start sedimentation, and this sediment product they will remain in the bottom is known as the cake. But in case of deflocculated suspension, the particle radius is very small and they will move rapidly and randomly. Sometimes there are similar type of ions are used to make them hang in the long time. For example, if the particle or any drug that is having the negatively charged, slightly negatively charged, so we can add some suspending agent that is also having somewhat negative charges. So once these ions are coming close to each other, they will start to repel each other and they will not allow them for the sedimentation, and the rate of sedimentation will be low. In deflocculated suspension, we can see the F value is generally 1, that is the initial volume will last long as the final volume. How we can go for the formulation of a suspension? There are three approaches, those are commonly involved, that is the structured vehicle, used of the controlled flocculation, and combination of both of the method, as we will discuss about the next slide. Here, finely divided particles are used, then after particles are added to the dispersion medium. The wetting agent is used, and the deflocculated suspension, we can see there are three different type of the method: addition of structured vehicle, flocculating the agents, and flocculating agents are added. Deflocculation suspension is external vehicle, flocculated suspension, addition of external liquid vehicle, flocculated suspension in the external liquid vehicle. First we have to take the suspension that we have to prepare. First we have to take the solid material, then we have to add the wetting agent or the suspending agent. If we have to make the deflocculated suspension, we have to make the particle in the smaller side, the flocculating agents are added and flocculated suspensions are prepared. For the long time stability, we are adding some structured vehicle and the suspension will remain hang in the suspension for a long time. What are the different ingredients? Those are used for the formulation of suspension. First one is known as the wetting agent. They are added to disperse solid in the continuous liquid phase. Generally, the surface tension is reduced by the help of the wetting agent. If the particle is having more surface tension, then the solubility or the wetting phenomena will decrease. If you are adding some amount, if you are adding the wetting agent, the surface will become, the attractive force or this surface tension will reduce, and that will helpful for the that continuous phase and the disperse phase to remain for a longer contact duration. Flocculating agents, they are added to flocks the drop particle. As I told earlier, the particles which has to remain for the long time, we are adding certain type of suspending agent that is known as the flocculating agent. They are added to form the flock so that it cannot settle down easily, or else it is settling down, we can redisperse easily by applying some forces. There are certain thickness are used. As I told, if the density will increase, then rate of sedimentation will decrease. So the thickness are generally used for the thickening of liquid medium. So increase the bulk and increase the density of the medium, liquid medium. So they are adding to increase the viscosity of the suspension so that the rate of sedimentation will be decreased. Buffers and pH adjusting agent. As we know that some suspensions are used externally and some are used internally. So if you are taking any suspension, those has to be given through the IV route or through the ophthalmic route, it has to be adjusted pH. As we know that our pH of the blood, that is the biological fluid, is having nearly 7.4. So before we use the suspension internally, it has to maintain the proper pH range. Osmotic agents, as we know, our body is isotonic with 0.09 percentage of sodium chloride solution. So if the osmotic pressure is not maintained and that is given to our body fluid, we can see that there is chances of hypotonic and hypertonic or hypotonic effect that may damage to our cells. We can add some amount of coloring agent because we have to increase the organoleptic characteristics, that is the color, order and taste. If the suspension color is not uniform, if these kids are taking, then that is not acceptable by them. So in order to enhance the elegance property of a suspension, we are using particular type of color which are approved by that FDA. Preservatives. Generally, if you are taking any kind of ingredients, for example, that may be a suspending agent, that may be used polymer, and it may have some sugary content. So, and sometimes it may have some aqueous vehicle. So, there is chances of growth of microorganism, and it has to preserve for a long time. So, in order to avoid the microbial growth and the destruction of suspension, we have to add the preservative. So, it will protect the microbial growth. The external liquid vehicle sometimes used to construct the structure of final suspension. Next, we have to go for the evaluation of suspension. That is, first one is the sedimentation method, as we discussed just before few minutes. As we discussed about the suspension of evaluation, first one was the sedimentation method. As I told earlier, see here, whenever we are keeping the suspension here for a long time, it will remain for a long time and it will settle down slowly. We have to denote how much time it is requiring to make it final settlement. The comparison The comparison is known as the sedimentation method. Second one is the rheological method. We have to determine the viscosity of the liquid. The viscosity of the liquid, if the viscosity will more, then we can see the rate of settlement will be less. Then electrokinetic method. In the electrokinetic method, we can see that we have to observe the zeta potential, and if those are the zeta potential is more, then the rate of sedimentation can be easily determined. There are different type of a microbarometric method by which we can determine the quality of a suspension. We can see that we can use certain type of Cowler counter method in which there is some pore is present and it has to be moved to the pores, and number of particles which are having the same size can be determined easily by taking the photograph. So we are just going to conclude the chapter of suspension, which is coming under the colloidal, non-colloidal suspension. We have studied all those. First we studied about the definition, we studied about the different parameters, then we studied about the sedimentation volume or sedimentation height. We studied about the use of F. What is the factors which are influencing rate of sedimentation, degree of flocculation. We studied about the Brownette movement. We studied about the different electrokinetic properties. We studied and differentiate between the deflocculated and flocculated suspension. We studied about the formulation of suspension. different ingredients which are used in the suspension, and evaluation of suspension. Thank you. We will start the other class of. Thank you.